Okay, hello world. This has been this video is going to be a requested video from some people. They've wondered how to calculate a walk-in cooler box. Some people have expressed interest in it, so I'm going to do my best here to touch on the subject, and you can tell me down in the comments if you want it to be if you got enough information, or you guys want some more detail, or what you want detail on. Just we'll see how this first video goes. It could be quite a long video. I'll try to keep it as short as possible because there's a lot to calculating calcing a box. Calculating the amount of BTUs required, or the amount of refrigeration BTUs required to cool a box under what different circumstances. Excuse me. So let's get into it. I'm going to be pretty much going from top to bottom, left to right, and as I'm talking. So let's see if I can do this. Let me adjust the camera here just a little bit to see if I can get it a little bit more on screen. All right, should be it. All right, so this picture, as you see here, is the walk-in cooler. This is your walls, wall temp on your walk-in cooler. Here's your box dimensions. See if I can use a pointer. I'll use a pen. Okay. So what you have here, this is the calculation program. This program was given to me free a long time ago, so it's not available. So everything will still apply to whatever program you were to use. So I'm just going to go across what we got here. So you've got the box right here. Hopefully you can see that. Maybe when I move the cursor, it'll. Let me see if I can go across here. Let me just back and let me F10 to exit here and see if I can go across the top. Okay. So trying to make the mouse the thing. I don't think I can go across. This is an old DOS program. But anyways, let's just get into it. Anyways, this is the actual box. Like I said, the wall temperature. This is the temperature outside of the box door. This is your ceiling temperature, floor temperature. Okay, these are your wall temperatures around the cooler. Your box dimensions. Let's say the cooler, my mouse. It's a. Let's say we're going to work with a 10 foot by 10 foot. So we got 10 by 10, 10 by 10 cooler, 8 foot high inside. Okay, so wall temp in a hot kitchen. Figure if this walk-in cooler is not in a hot kitchen or whatever, you can change these temperatures, but these are just defaults. I just leave them at the defaults right here. Outside the box door, in the kitchen could be 95. So you always want to leave yourself a little bit leave the defaults, or leave the leave them where they're at. So anyways, floor, this is for a concrete floor. If it was an insulated floor, you could you'll change that. I'll show you in the programming what you can do here. So let's just see right now. So we got a box that's 10 by 10 by 10. Our ambient, our maximum day ambient is 95 degrees. We're saying right here. Okay. So there's your cursor. I don't know if you can see. Hopefully you can see. Yeah, you can see it's moving. Okay. And we want to be able to do 33 degrees. You can set that to 35 or 36 or whatever. But I like to have my boxes calc just a little bit heavy. So we have different selections for different parameters that change with the box. So the product, the amount of product, whatever product going in, you can determine. You can select product. If the cooler is only going to have one type of thing in it, or two types of things. If it has general storage, I go with the default. Miscellaneous will give us like compressor runtime, that kind of thing. We'll have the insulation is very important here. This is very important that this be your standard walk-in cooler is going to be a 3-inch wall, 3-inch wall, 3-inch, all the walls 3-inch walls, and a 3-inch roof, and a concrete floor. That's your basic walk-in cooler. If it's going to be anything different than that, you want to change that. If you're doing a drawers, built-in systems or something that only have 1 inch of insulation or 2-inch of insulation in the wall, and it's probably not going to be foam insulation. It's probably going to be fiberglass. If it's 30 or 40 years old, 20, 30, 40 years old, it's definitely going to be fiberglass insulation in the wall. So you got to select your insulation value. If you ever ask a supply house to calc something for you, you need to tell them the things that the standard operating procedure, whenever a supply house, they're calcing a box or whatever, they'll figure it's got, you know, foam in the walls, your standard walk-in cooler, concrete floor, 3-inch walls, foam in the walls, you know, that kind of thing. It's going to be different. You need to tell the supply house if they're calcing it for you. If it's wood box, if it's 30, 40 years old, you're going to want to calc heavy. Your insulation could be junk in the walls, you know, so maybe sometimes you even want to drill a hole in the wall, see how bad the insulation is. If it's all wet, you know, you really want to calc out heavy or replace the cooler. So let's get into it a little bit, and we'll see where we go from here. So right now we've got a box that's a 10 by 10 by 10, about 8 foot tall, with a maximum ambient. Your hottest day of the year is 95 degrees. Okay, and this would be a standard walk-in cooler that's just in a, you know, someplace in a restaurant. Okay, so we'll go F10. We'll exit here, and it will give us the amount of BTUs. So you would need to put a 12,000 or 13,000 BTU evaporator in there. Your total load is 11,000 and change BTUs. 10% safety gives you 12,000 BTUs. So 12,000 BTUs is pretty common evap, or 12 or 13,000, you know, whichever your manufacturer, whatever has. Again, these are your defaults. Like I said, 3-inch on your insulation, your walls, 0.14 K factor, urethane panels, 1.5 K concrete floor, 6-inch concrete floor. This is all standard defaults, standard operating procedure for your standard cooler. That's, you know, concrete's always going to be 6-inch concrete floor, and some walk-in cooler manufacturers these days might be doing 4-inch walls. You might want to change that. You don't pick up a whole lot going from a 3-inch to a 4-inch wall. It does not reduce your BTUs much. I would not even worry about it. You can change it or whatever, but you only pick up a few hundred BTUs when you go from 3-inch wall to 4-inch wall. The money place is at 2 inches. When you go from, you know, 0 insulation to 1-inch insulation, 2-inch insulation, those are your big jumps. When you go from 2-inch to 3-inch, a little bit of a jump, but anything more than 3-inch of insulation, you don't pick up a whole lot of insulation quality. Like I said, 2 inches is really that's really where the money changes right there. So so you got runtime hours of the compressor. I set it at 12 hours. Coolers on this particular program, we'll see miscellaneous. We'll go into our runtime. You should be able to see they suggest 20 hours. 20 hours for coolers. I don't want my cooler running 20 hours a day, so that's why I changed my default to 12 hours. I like my stuff to be capped a little heavy. So let's see at the default. You can see what happens when you change this. We're going to change this to 20 hours for cooler, you can see, or 18 hours for freezers. 20-hour runtime. Let's hit F10 to exit here, and now for the same size cooler, your 10 by 10 by 8 foot cooler, you only need 8,000 BTUs of so that would be the smallest evaporator you could put in there. If you had really light load, nobody, where they barely open the door, or they use it just for storage, it's in a medical facility or something like that, and they don't go in the cooler at all, you could even probably get away with, a 7,000 BTU evaporator, because there's no infiltration load, real light duty. So again, we'll talk about infiltration load, how many doors something has, if it's got glass doors, what they're doing with it. The product entering temperature, it enters at 48 degrees with a pull down of 15 degrees. So in a 24-hour period. So these calculations are all to the product enters the cooler at 48 degrees, and to do a pull down of 15 degrees down to 33 degrees here, it takes 24 hours with these specifications. So that's why I always figure it's a good rule of thumb is 1,000 BTUs per foot on a walk-in cooler. So a 10 by 10 walk-in cooler that's got an 8-foot ceiling height, it would be a 10,000 BTU cooler. And as you can see, they're saying basically 8,000 BTUs here under light load, 20-hour runtime. Let's change that runtime to 12 hours now. Okay, the 12-hour runtime. You put a bigger compressor on it, bigger evaporator, bigger compressor. You put in a 12,000 BTU. Now you're gonna get it's gonna do the job quicker. Okay, with a 12-hour runtime. The only time you get into problems, if you size it way too heavy, like 200% heavier than you need, then you could get into short cycling issues. If the ambient drops down to 75 degrees, or you guys need to make adjustments for if you're in cold climates. This is California, so our climate basically is from we get a few freezing days, but it's not very often. 35 to 120 degrees out here, so that's our temperature range out here. So I always, because we like today is 90, 100 degrees, so you always want to get your ambient up there. And let's change our ambient too. See what we get here with probably won't change the ambient, usually doesn't change it much. It's the amount of runtime. So let me go to ambient. I gotta go backwards here. Okay, to the box. Okay, and there's my ambient right here, 95. Let's say it's 110. Okay, so and all right, let's F10 exit out of that. Pretty much the same BTUs. Okay, so okay, so product. Okay, general storage. Right now we're just working with 1,750 pounds of general storage. They just figure the 10 by 10 cooler, and I just leave it at that. 24-hour pull down. Maybe you want the product to pull down a lot quicker than that. Right now we need 12,000 BTUs. Let's see if we can change our pull down time. Our run time is 12 hours right now. Let me see if we go box doors. Hey, you want to do this? Okay, number of box doors just for one walk-in cooler door. Usage factor, this is important too. 1 is just normal usage, normal walk-in. If it's a really busy restaurant and they're just in and out of that thing never shuts, the door never shuts, you want to kick that usage factor up to 1.5. If you're having supply houses, calc a box for you. You need to tell them if it's a normal, if it's a heavy, heavy usage, or long-term storage where they hardly get into the cooler. All these parameters will change your BTUs. So let's go. Right now we're at 12,000 BTUs with one cooler door. Okay, at normal usage. Let's go up to a 1.5 heavy busy restaurant. Okay, want to kick that BTUs. See, your keep BTUs now required are 15,000 BTUs from 12,000 where you were before. So busier restaurant requires, because the door keeps open and closed, the heat goes in there, has to pull more heat out. So you have to deal with that. So insulation. Okay, and this is where you go into a different one of these, but that's just for the hell of it. Let's say it was an old cooler. This would be a normal cooler, these days cooler within 10 years old, 20 years old. Let's say it's an old cooler, and it's so this is 14,000 BTUs right now on a heavy load. Let's change this to the old fiberglass. There's an old fiberglass cooler with a 6-inch wall. Let's see what that does. Alright, so let's go fiberglass. Okay, fiberglass with a 6-inch wall. That's what the old coolers were. Still concrete floor. F10 to exit. See if our BTUs, see, they don't change much. From 3 inches of foam equals 6 inches of fiberglass. So it went up a little bit, up 1,000 BTUs, but as you can see, we're at 15,000 now. And but if that wall was only 3 inches of fiberglass, let's see what we got now. We would need 19,000 BTUs. See, that fiberglass is not very good for insulation, so that's why we use foam these days. So anyways, let's go back to our to our urethane, and 3-inch default. Okay, urethane. There's your foam, your urethane foam, 3-inch. Okay, F10. Alright, so, and let's do our runtime at 12 hours. You're gonna probably be calc'd for 20 hours from a supply house, you know. So that's what they're gonna sell you, 9,000 BTU on a 10x10 cooler. Probably runtime. See, default 20 hours for cooler. Box doors 1. That's a heavy load right now. We're calc'd at. Normal load. You can even. We got 7,800. So basically 8,000 BTU is required. 8,000 at a normal load. If we go with a 1.5, we're at 9,000. So we need an extra 1,000 BTUs for heavier usage. 1,000 BTUs on extra on a 10x10 box, every 10x10 probably. Equipment. Let's see, box doors. Number of box doors. Okay. Let's say we had two doors, or maybe 3 doors. I've seen coolers with windows and doors and stuff on them. So let's say we got an extra. Or let's say we got an extra couple. Yeah, a couple 3 doors. Okay. So we got 3 doors. Normal usage of 10, 13,000. So you got lights. Figure lighting in watts per square foot. 1 doesn't really, that factor doesn't matter much. The equipment, if you got forklifts going in and out, then you got use 12 horse at 8 hours for. Anyway, so that's for forklifts. Not much of us. Not much of us are doing that. So material handling, glass doors. This could be a biggie, you know. So right now we need 13,000 BTUs, and if we add a couple of glass doors, say we add 2 glass doors, and the temperature adjacent to the glass door is a hot restaurant, so 95. So F10, we're at 13,000. Now we need 3,000 extra BTUs because of glass. glass doors. So all these different things need to be taken into consideration. So no glass doors. Okay. Okay. People don't have to worry about that unless you're doing a prep room, you know. So main menu. Okay, so with a runtime of 20 hours for a cooler, which I don't like. Let's see, we got runtime 20 hours. We got 3 box doors. So we got to change that. So you want to get back to 1 door. Okay, 1.5. Most restaurants, if they're a busy restaurant, you want to go with a 1.5 heavy calc. Okay, so all right, so box doors. We're at 1. Runtime 20 hours. Okay, equipment, glass doors. The glass doors are 0. Okay, so all right, so that's that. We got general storage, a couple thousand pounds of food. Change that if you want. Lighting, fan load. That's from the evaporator fans. 1,000 BTUs from the 2 fans. So you would do, if you're doing your runtime of 20 hours, which is suggested for coolers, 9,000 BTUs. You want to, if it's hot, if it's Riverside, you're going to want to get that thing down to 12. Okay, so you should be putting in, instead of you want to be putting in 15,000 BTUs. If it's always, if you got a lot of days that are 110 degrees out, and you don't want it to be running all darn day, you know. This is 12 hours would be only 50%, a 50% duty cycle, you know. So you'd be 30 minutes on, 30 minutes off. That, you know, 20 minutes on, 20 minutes off. And that's the way I like them to run. 20 minutes on, 20 minutes off. So so that's why I calculate 12 hours. You could calculate whatever you want if you get your own program. But like I said, so the heaviest you would do would be 15,000 BTUs. For let's see, you can calculate the heaviest and then the lightest. So 12 hours and 110 degree ambient. So now let's change our ambient to okay, let me see, F10. Okay, where am I at here? I'm trying to, okay, box. Okay, so I'm trying to get back to the box. Okay, haven't used this for, okay, so we go back to 95 ambient, 10, so okay, we got let's see what we got. Okay, so your runtime is what's gonna do a lot of change here. So 12-hour runtime is 15,000 BTUs. Or if you do a runtime of 20, (9,000 BTUs. So somewhere between 9 and 16,000 BTUs, basically, you can size the box anywhere between there. Experience and tell you, you know. So choose the midway point. You know, if you want to be, if it's hot there, if it's cold, you go with the. If it's always a cold location, you can go on lighter with lighter usage. So it's going to be somewhere between 9 and 16,000 BTUs. So you can, it'll do the temperature depending on the amount of people going in and out and product going in and out and all that kind of stuff. So that's pretty much it. I think I've covered. Yeah, so you could go if they're saying 20 default. You think 12 hours is too little? You could go, 16-hour runtime to make it a little heavy. So there's your. Okay, so you got runtime of 16 hours. General storage. 11,000 BTUs, 3-inch walls. There you go. I'm trying to figure something else. There's a pull down thing. Oh, it's in the general storage. Yeah. If you change the the storage, the product going in, you can change your rate of pull down. So right now we have a runtime of 16 hours. Okay, on a 95-degree day. Going to run for 16 hours, 12,000 BTU evaporator. Okay, if you change your product, and let me see, I think I haven't done this in a while. First product. Okay, if I check if it's going to be meat, fresh mixed meat. Okay, going in there. You can now enter the pounds of meat. Say it's going to be 1,000 pounds of meat per day. Entering should never enter at 48. So the should be like, let's say it comes in at 41, 42 degrees. Say 41 the max temp. Box temp at 33. Pull down hours. If you want that meat to pull down fast and not be 24-hour pull down. Say if you wanted a 12-hour pull down in 12 hours from 41 to 33 degrees. Well, let's say you wanted it to pull down within 4 hours. So we want to pull down 4 hours. Okay, so we've changed our amount of product. Our BTUs is 11,000 BTUs required right now. Let's go F10 exit. So you need an extra 1,000 BTUs to pull that product down. We've changed our product. We were at almost 2,000 pounds of product. Now we're cut our product in half with a 4-hour pull down time. So we need to go up to 12,000 BTUs. So say our second product is another 1,000 pounds of something. So let's say, we got it. Oh, come on, stop it. Things going fast. Let me see. We got, I wonder if we got some miscellaneous storage, if we can change. Yeah, we can change with miscellaneous storage let's say another 750 pounds of product, but it's entering at a little higher temperature. Maybe it's oranges and all that kind of stuff and salad type of stuff that comes in maybe 48 degrees. So and if you want it to be ready in 4 hours, that product to be ready in 4 hours down to its 33 degree box, you're going to need to go up from 12,000 BTU to a 15,000 BTU evaporator. So you guys see kind of what's going on with this here. That's a little bit more, but as you can see here, so if you're calculating your own, yeah, I could use the mouse here. Your first product, 1,000 pounds of meat, fresh mixed, requires 4 hour for a 4-hour pull down to get that product down to 33 degrees in 4 hours. This amount of BTUs it's required to do that. And this is what you should be looking at a printout probably if you get a supply house to do, especially if it's anything more than a regular 10 by 10 cooler. If you got a bigger cooler, you want to see a printout and see all the parameters that you want to make sure it's right. So and your usage, your really important stuff is how much you want that compressor to run on a hot day. If it's 100 degrees out, I don't want the compressor running any more than 12 hours of that day, you know. So I like my compressors to be run 20 minutes on, 20 minutes off. So that's a good thing to have. So your things you want to look at is your run time, your ambient box temperature, amount of time you want it to get for that product to get to temperature, and the type of box it is. If it's old or new, your wall thickness, urethane, fiberglass, or whatever. Let's do another one here. If you guys can step out now if you want to, if you've heard enough. Or I'm going to do one now that's going to be a like drawers for like a built-in system, an old 30-year-old system, 40-year-old built-in. Let's say it's got drawers. It's a cook line. We'll do a cook line here. So let's go out of here. The boxes. Let's say this box is going to be okay. The ambient in the kitchen is 100 degrees, no problem on the cook line. We want, let's say, a 35 degree box. I'm gonna do 33 just to give myself a little extra edge. Box dimensions are going to change now. Here, I got a cook line that's probably, it's about 20. Well, let's do one section of it. Okay, one section of this cook line is 6 by 4, 6 foot by 4 foot, by only about 3 foot tall. Okay, so this is a cook line that has, let's say it's got 4 drawers on one side. Okay, there's your wall temps of this cook line. A box door 95 easily. So ceiling 115. We'll change that because the ceiling in this room, it'll be a cook line, so it'll be 100 on the cook line. Floor 60. We'll get into that, and I'll show you where you change for insulated floors and that kind of thing. So now we're going to go into the product. We're not going to worry about. I'm going to exit here. So right now we have 6 foot by 4 foot by 3 foot high cook island. Okay, it's going to have 4 drawers in it on one side and one door on the other side. It'll be 2-inch insulation fiber. It's got only 2-inch insulation. 1 or 2 inch. I think it's 2-inch insulation. So right now we got to change our insulation. So we'll go across here. I want my run time again. I'm going to set my run kind of 16, so that's fine. Box doors. Okay, there's your box doors. Each drawer is going to be considered a door. So 4 drawers and 1 door on the other side. I'm going to put 5 doors in this. As you see up here, number of box doors 5. Usage factor 1.5 for drawers. Cook line, very heavy usage. So you want to lights. Not going to worry about that. Equipment, lights, we can go into that. It's got no lighting. Actually, it might have a light. Don't worry about it. Equipment, glass doors. You configure the top. Open the prep table area as 1 glass door. Okay. No people inside. Main menu. Okay, let's go back to that. Okay, so a 6 foot by 4 foot. Okay, we need to change the insulation. Okay, insulation. So we need to go with fiberglass down here. It's going to be fiberglass, 2-inch only. Go fiberglass. Okay, fiberglass, 2-inch, insulation, concrete floor. No, it's going to be an insulated floor on those, most likely. This one is. So, because it's a stainless steel cook island with an insulated bottom on it. So you're going to change that to fiberglass, and again with your 2-inch floor. Might only be a 1-inch floor. You got to check on that. So F10 to exit. So 12,000 BTUs. Look at that. So a 10 by 10 by 8 foot walk-in cooler is about the same size as a 6 by 4 by 3 foot high cook island. Check that out. So that's why they're so hard to get to temp. You gotta be able to put in 12,000 BTUs worth of evaporators down there. That's a 4-hour pull down. We need to change our product and stuff. Let's get that back to where it's gonna be. I'm not gonna have 1,700 pounds. So that's way off. So let's see what our numbers are gonna be. So product, let's go. Let's go general. See if we can go general storage. Okay, that's default 128 pounds general storage. So 24-hour pull down. See how your BTUs changed? Huge. So got to pay attention to the amount of product that's going to go in there. So I know about what they put in there. Drawers and everything like that. It's going to be a little bit more product than that. There's going to be probably about 300 pounds, because the drawers are going to be about 50. You're going to have and you're going to have a couple. The other side is going to have product, so I would like to at least be around 200 pounds of product. So we'll go with first product, and I'm going to go down, see if I can put, if they get miscellaneous storage. Change from general to miscellaneous. You get amount to select your amount of pounds of product entering. Could enter at that temperature. Pull down hours. We want to be 12 hours of pull down. We want to. So F10 to exit. So you need 7,000 BTUs with a 12-hour pull down. Maybe even we go with a little bit. So that's 200 pounds of product. And let's say our pull down hours, we wanted 4 hours. Should be nice. We're gonna have to go up we can get that. See, we can just extra 600 BTUs to really get that product to pull down quickly. So 200 pounds of miscellaneous storage for your we've got 5 box doors. That's our infiltration heat load. Every time you open and close the doors. So 1 glass door. Figure that for the top, for the prep area. The containers coming in and out the top. And 2 inches of insulation. So you're going to need 7,600 BTUs in that 6 foot wide by 4 foot wide by 3 foot tall thing with drawers and stuff in it. So that's why you need to put in those 2,000 BTU like an RAMK, 2468. So you need 4 of those evaporators inside that thing. So that's what this unit basically has in it. 2 on one side and 2 on the other. So you got 4 evaporators. They're about 1,700 BTUs, 35. So 7,000 BTUs they come in at. So it's sized right. So these are really helpful. So hope this video has been helpful, and hope this helps you guys. Tell me what you want to. You got questions on what you want anything else, any other questions answered. Alright, I know it's been a long video, almost 40-minute video. Actually, it just clicked over 40 minutes. Whew. Alright, so hope this helped you guys. I know it was a long one. So hope you liked it. Click like on the video if you could, and subscribe, and comment down below what you would like to know more about regarding this, if anything, or if I covered everything. I think I pretty much covered everything, but anyways, let me know. If you want to find out what K factor is, you can Google that. 32 K factor, C factor, different factors for fiberglass for insulation. I'll try to put a link on. I found a good article on that. I'll try to put that link in the comment section. I'll try to pin it. All right. So click like on the video, subscribe. Take care, guys. Hope you're having a good. Try to get this thing for you for Sunday morning. All right. Take care. Bye. So that's that.